All right, as usual, we're going to try to document our latest test here. So we have tried the internal type of cap, which is what this cap is about. You can see that hollow set screw, and it has a vent hole in the bottom right there that goes up into a chamber that contains a hollow aluminum sphere that then pressed up against an O-ring at the bottom of this hollow set screw, and that was supposed to float up and seal, but it was unable to effect a good seal with that single source of contact. So then we tried the external attachments, the shutoff valves on top of our fuel caps, and that's what we're looking at right there. The one on the left was the tall 0.33 cracking pressure, and the one on the right was the 1 psi cracking pressure, and those were still inconsistent for us. So now what we're going to try to do, based on Dan Bauer's recommendations, is we're going to try to go back to our system that we had with the open vent, so that the default position for our system is to be open, so a vented tank. And then when we need to temporarily close off the vent to keep the siphoning fuel from the external tank from overflowing, then we'll just shut it off. But our normal position is going to be open. So to do that, I've modified one of our internal caps here. So if you look at, here's one of the internal caps. It's probably a little hard to see in there, but it's real rough, and it's got ridges, and it's just not a smooth surface in there at all. So what I did was, it turns out this 2-inch grinding wheel was just perfect for going in there and smoothing all that out. I had to remove the rubber gasket, and then I started with a 60 grit, then went to 180 grit, and then finally 180 grit, and so this is nice and smooth now. And that's important, because what I'm going to try to do is seal against that with one of these little rubber discs that I got from Cardinal Rubber Products here in Rock Hill. And what this actually is, this is out of a gasket that they made for a heavy-duty gasoline pipe installation, so it's impermeable to gasoline. I can't remember what the lady said it's called, something like I can't remember. Anyway, this is actually where they cut out a hole in the gasket material for a bolt to pass through. So I got a couple of these from her, and it's just about the perfect size for me. So what I'm going to do is put this inside the cap and hope that we can get a good seal against the bottom of the cap with that rubber seal there. Okay, so just to continue, so here is our little rubber disc that's going to hopefully slide up and seal against the hole inside our cap. But these rubber discs do not float. They sink like a rock in gas. So I needed some way to float that rubber disc up against the vent hole, and that's why I selected this small piece of balsa wood. But of course I didn't want the balsa wood absorbing fuel, the gasoline, and losing its buoyancy. So a couple of days ago I soaked this balsa wood in this fuel tank sealer to make it impermeable to gasoline. So what we're going to do is turn the cap on its side. I'm going to place the little rubber disc right where we want it, because it's off center just a little bit. And then I have a needle that I'm going to, I went to Hobby Lobby and got a long needle, and I'm going to be pushing that needle through the cap from the top. So it'll push down into the rubber disc, and then I'll hold the float against the rubber disc and push the needle down into the float. So it'll be passing through this long, it's about 3/4 of an inch long hole, this very small hole. The needle just barely fits through there, so there is a little bit of space for air to pass through to work as a vent. And then with the needle sticking out the top, I'm going to tie a piece of a toothpick to the top of the the needle so that it'll keep it from falling through all the way through the cap and down into the tank. But it will also be a visual indicator of whether the float is in the vent position or whether it is sealing off the tank to prevent overflow from the external fuel. Okay, so we have positioned the needle through the rubber valve, the thing that's going to seal. There's a needle on the top side of the cap, and it's forced through the rubber. It's very tight, so we're not going to get any leakage around the needle where the needle goes through the rubber. Okay, we're ready for the next step here, which is going to be impaling our balsa float on the needle to provide the buoyancy to make the rubber stopper move up and down and hopefully seal against the bottom of the cap. Okay, that seemed to work out well. We've got the needle sticking through the rubber stopper and into the balsa wood float with about a ½ inch or so of needle sticking out the top of the cap. Okay, so we have our little piece of toothpick tied to the top of our needle that like right now it's sealed off. It would be sealed because the float touches the table when it's sitting like that. But once it's vented, then the needle will be down because the float and the sealing disc will be pulled down away from the vent hole, and then hopefully once the fuel refills, siphons into the tank, then it will the float will push the little rubber disc back up into place and seal off the vent hole. So we're going to remove the quick disconnect from our earlier cap that had the 1 psi cracking pressure valve, just because this one's a lot easier to get out than the one with the 0.33 psi cracking pressure, because it's got that tall nipple on it. Okay, there you have it. A little bit of Teflon tape on the bottom of the quick disconnect fitting, and then screw it into the top of the cap, and we're ready to put it on a generator and connect an external tank and see if it'll shut off the flow. Okay, so the fuel level is about an inch down below the red ring inside the filler neck. So that'll be a good place to start, as we know that the vent will be open when we start. Our little toothpick ought to be sitting down on top of our fuel cap, and then when we connect the external tank and start the siphoning action, we'll be able to tell whether we get a good seal or not. Okay, so we've got the cap screwed on, and the the vent is loose. Right now the little toothpick is down against the top of the cap, so it's I can move it up and down so we know it's not being impinged on the side of the filler neck. Okay, for this test we're going to start off with the fuller of our 2 fuel tanks, and the fuel level is right about even with that seam right there. So we're going to hook it up to the quick disconnect on the generator and see what we get. Okay, it's recording. I'm going to plug in our fuel quick disconnect. It is plugged in, and we've got a good vent. The vent is open on the external tank. I think I already see some little bit of fuel is spraying up out of the hole. So I think it's venting right now. I think that I don't know if it's being captured by the camera or not. Let me scoot it over here a little bit, get just a little bit better angle. But there are little droplets of fuel spraying up out of the vent hole. So I think right now the internal fuel tank is being filled from the external fuel tank by siphon action. I didn't pump the squeeze bulb at all. I think the siphon just started on its own, and we're going to just watch it go and see if we can get a seal or not. So I'm seeing more and more action here as it seems to be getting close to be getting full. Oops, here we go. We are not getting a seal. We're getting an overflow. Let's see if I can pull that up. It's still not sealing. Even with me pulling up on the needle. So I don't want to pull so hard that I pull it out of the float. But even with me pulling up on the needle to raise the little rubber disc up against the bottom of the cap, I still can't stop it. It's a pretty significant flow out the side. I don't know if we captured all from over there or not, but yeah, we've got a significant flow, so it's a bust. We do not have a seal on the inside of the cap. So this is just to wrap up this test. My camera was getting too hot out there in the hot sun. It said to cool it off, so I moved everything back into the hangar. But you can see as soon as I disconnected the siphon hose, the leakage stopped, and the float is actually up against. We can tell because the toothpick is up at its maximum elevation, so the float is pressing up against the disc, and the disc is pressing against the vent hole, and it is actually sealing right now, but that's because there's no pressure. So it's the same story as when we had the little spherical ball pressing against the O-ring. It's just not the right setup to seal off fluid under pressure. I think to seal fluid under pressure, we're going to have a long, slender, conical shaped needle valve like they use in carburetors to press against a matching seat to get a good seal against fluid pressure. And this is just to document that when we do remove this cap with the internal float, the fuel level is right up to the top of the filler neck. So it did siphon until it was completely full, and then it started overflowing out the vent hole, and we were unable to get a seal with our little float pressing against the rubber seal there, even though I had smoothed everything off to a nice smooth surface.